This video will cover the topic, solving an equation with a root index greater than 2, problem type 2. A root index is the number outside the radical that tells you how many times a number is multiplied to result in the term under the radical sign. Let's look at an example problem. Solve the equation for w where w is a real number. Before we start this example, we should review the following property. If a equals b, then a to the n equals b to the n. So we need to raise both sides of the equation to some exponent n.
How can we find what n is?
Well, we need n to be a number such that it eliminates the radical sign from our equation, and this number is 3. This is true because the cube root of a term is equivalent to that term raised to the 1/3 power. And x to the power of 1/3 raised to the power of 3 equals x to the power of 3 over 3, which equals x to the power of 1. So when our root index is 3, our n should be 3 as well. And we have 5w minus 12 to the power of 1/3 all to the power of 3 equals 2w minus 3 to the power of 1/3 all to the power of 3. This results in 5w minus 12 equals 2w minus 3. Now we need to isolate w to one side of the equation. Do you know how we do this?
We need to eliminate it from one side of the equation, so we'd subtract 2w from both sides, right?
Yeah, that's right. Our result after this operation is 3w minus 12 equals negative 3. Now that we have w on one side, we need to eliminate any other terms on that side. We do this by adding 12 to both sides of the equation. This results in 3w equals 9. Our final step is to divide by the coefficient of w, which is 3. And our answer is w equals 3. We can check our answer by substituting 3 for w in the original equation. After simplifying the terms under the radicals, we can see that our answer is correct. Let's do one more example. Solve the equation for y where y is a real number. In this example, we only have a radical on one side of the equation, so our first step is to subtract 3 from both sides of the equation so we can isolate the radical. Again, we need to use the property if a equals b, then a to the power of n equals b to the power of n. We can rewrite our equation as 9y minus 9 to the power of 1/4 all to the power of n equals negative 3 to the power of n. What should our n be?
Well, since our root index is 4, shouldn't our n be equal to 4 so that we can eliminate the exponents from the left side of the equation?
That's correct. This results in 9y minus 9 equals negative 3 to the power of 4. And negative 3 to the power of 4 equals 81, so we have 9y minus 9 equals 81. What should we do next?
We need to isolate y to one side, so we would add 9 to both sides of the equation. Then we divide by the coefficient of y, which is 9, and this gives us our answer of y equals 10.
Great job! It looks like you're really starting to understand this topic. But is our work done?
No, we should check our answer by substituting 10 into the original equation for y.
Yep, you're right. So we have the fourth root of 9 times 10 minus 9 plus 3 equals 0. We can simplify the terms underneath the radical sign, and this gives us the fourth root of 81 plus 3 equals 0. The fourth root of 81 is equal to 3. But 3 plus 3 equals 6, not 0.
Oh, so what does this mean?
This means that our equation has no solution, since y equals 10 is not a solution to the original equation.
Okay, I think I understand. First, if there's one radical, we need to isolate it to one side of the equation. Then, using the property if a equals b, then a to the n equals b to the n, we determine what n to use based on the root index. If we choose the right value for n, it should eliminate the radicals from our equation. Then we isolate the variable to one side and solve for it using the necessary mathematical operations.
You got it!